In this video, we're going to go through section 6.6, solving radical equations, in case you missed something in class. So, going through some examples quickly, if we've got the only way to undo this square root is to square both sides. And so, first thing we're going to do is just square both sides, and then this 4x minus 9 pops out, but we have to do 5 squared, which is 25, and now it's just a linear equation. We subtract 9 on both sides. We get 4x equals 25 minus 9 is 16. We divide by 4, so x equals 4. We could plug that back into the original equation for x to check to see if it's true. Sometimes some weird things happen with square root equations, radical equations, but this one should work out. 4 times 4 is 16, and then there's like secret parentheses here. We do square root of 16 plus 9, which is 25. And 5 equals 5, so it works. Next one. So if you see x to the 1/2, remember that's the same thing as square root. The 1 is here and the 2 is there. So then we just treat this, we add 4 to both sides since the 4 is outside of the square root. So square root of x equals 5. Now we square both sides to get rid of that square root sign, and we get x equals 25. We could plug it back in and check, and it should work. Okay, next one, we got this 7 and the minus happening outside of the square root, so we need to deal with that first. So since this 7 is positive 7, we have to subtract it to the other side. Now this minus sign is still here. It doesn't just disappear magically. And negative 6 minus 7 is negative 13. But now, to get rid of these negatives, we can multiply both sides by negative 1, and they become positive. And now we can square both sides to get rid of this square root. So x minus 4 pops out. 13 times 13 is 169. And then we add 4 to both sides. So x equals 173. Okay, example 4. This is where things start getting weird. If you have square roots on both sides, the only way to get rid of it is to square both sides. In doing so, some weird things sort of happen mathematically. So it doesn't seem that weird right now. We pop out the x minus 5, and this just pops out 5x minus 1, and we solve this for x. So we want to get x on one side and the numbers on the other. I like to keep the x's positive, so I'm going to subtract the smaller one from the bigger one. So now we just have negative 5 equals 4x minus 1. And then we're going to add 1 to both sides. So we get negative 4 equals 4x. And then to undo this multiplication, we divide. And we get negative 1 equals x, and we think, okay, everything's good, until we check our answer. So if there's square roots on both sides, you really should check your answer. Plug in negative 1 in for x, and see what happens. 5 times negative 1 is negative 5, and then minus 1. So just plugged it in. Now it looks maybe okay. Negative 1 minus 5 is negative 6, and negative 1 minus 5 is negative 6. Everything looks okay, but the problem is these are not real numbers. The square root of negative 6 is not a real number, and so negative 1 sort of is a solution, but it's not really a solution. And when that's the case, we call this an extraneous solution. It sort of works. We got kind of a true statement, although it's a kind of a bogus statement. These are not real numbers. So it sort of works, but it doesn't. And the word for that is extraneous solution. Solution meaning it works, extraneous meaning it sort of doesn't work. Okay, and the last one, going back, I put no solution here. You could technically say no real solutions, technically. So, example 5. This is another case where some weird things happen. We have a square root on one side and a binomial on the other side with no square root. So if we want to cancel out, we have to get this x out of here. And the only way to do that is to square both sides. But now that means we have to square this left side. So on the right, it's nice, but on the left, we can't, remember, if there's a minus here, we cannot distribute this power. It doesn't work that way. This means we have to do x minus 3 times itself, and now we have to multiply it out using FOIL. So x times x is x squared, the outside is minus 3x, the inside is also minus 3x, and the last two terms give us 9. We still have this x minus 1 on the right, and now we want to combine like terms here. X squared minus 6x plus 9. Okay, now right here we have to notice something. We have an x squared and no other x squareds anywhere. So that means this is a quadratic equation, which means there could be two answers. So we want to try to get everything on one side and 0 on the other side in order to solve quadratic equations. So that means we have to subtract x. We have to subtract this x over here, and we have to add this 1 over here. And so what we're left with is x squared minus 7x plus 10 equals 0. And now if you remember, I mean, we could use the quadratic formula, but nobody really likes that formula. Instead, it's much better if we try to factor this. So what two numbers multiply to get 10 and add to get negative 7? Those would be negative 5 and negative 2. And then we have x times x is x squared. We're just undoing this multiplication that we did over here, sort of. So now these are our factors. We could check by remultiplying this, but it is going to work. This means that x minus 5 equals 0 or x minus 2 equals 0. And so that means if we just add 5 to both sides and 2, we get x equals 2 and x equals 5. Whoa, what happened there? But if we check these numbers into the original equation, some weird things are going to happen again. So when we check x equals 5, that means we just plug in 5 minus 3, and then there's a square root on the right. So we have to do square root of 5 minus 1. 5 minus 3 is 2. Square root of 5 minus 1 is 4. Square root of 4 is 2. So it works. X equals 5, definitely. But when we plug in 2, we get 2 minus 3 on the left, and we get square root of 2 minus 1 on the right. 2 minus 3 is negative 1, but the square root of 2 minus 1 is positive 1. These are not equal to each other. Therefore, x is not equal to 2. That is not a solution. It's another extraneous solution. It sort of works, but it doesn't work. So x equals 5 is the only solution to this equation.